Hi there, my name is Hossein Bahari and I'm a rehabilitation R&D engineer here at the Glen Rose Rehabilitation Hospital.
And I'm Kareen Tech, and I'm an occupational therapist here at the ICANN Center at the Glen Rose Rehabilitation Hospital. I'm also the clinical practice lead for our brain-computer interface project. Today we're here to present to you our pitch for our very cool project, we think, power mobility using SSVEP. So a little bit of background. Our ICANN Center for Assistive Technology, one of the major things that we do here for clients of all ages, pediatrics and adults, is to provide access to complex power mobility. Most people might be familiar with people driving power chairs using a single joystick with their hand. However, for many of our clients, they're unable to use their hands and unable to drive in this method. One of the most common methods for children who cannot use their hands to drive power wheelchairs is to use switches. Mechanical switches are placed at various places around the body. The child has to depress and hold one switch to go forward, press and release one switch to turn left, press and release one switch to turn right, and press and hold one switch to go reverse. Imagine coordinating all four of these movements in order to drive a chair. This is a very difficult skill for many children. And for people who have very complex bodies, this can be the difference between having mobility independence or being dependent on a caregiver for pushing you around in your wheelchair. One of our big dreams here at the ICANN Center is to have children use BCI to help drive a power wheelchair. Something important to know about power mobility is that all power wheelchairs are made by different manufacturers. All the chairs have slight differences in drive controls, driving abilities, switch abilities, and motors and batteries. It's very important that we have some sort of solution that's a more universal solution that can work with a number of different power wheelchair companies.
As Corinne mentioned, driving a power wheelchair with switch control can be challenging based on the physical capabilities of the patient. To overcome some of these challenges, we decided to incorporate BCI into our power mobility control systems. To do so, we thought that maybe we could use BCI to control the left and right directions instead of switch control. One of the commonly used BCI paradigms is the SSVEP paradigm. SSVEP works based on the different light sources flashing with different frequency. Long story short, your brain can pick up the frequency of a flashing light source, and you could record your brain signals and use that to detect which source of flashing light the patient or the subject is staring at. We are assuming that replacing only the directional switches with BCI would give us a robust enough system for power mobility control. Almost all of our power wheelchairs can accept jelly bean switches as an input. So the hardware-software package designed by the student's team should have two flashing light sources flashing with different frequencies and should be capable of detecting which light source the patient is looking at, and also send an output signal through an audio jack to the power wheel. There are various benefits to doing such a project with our team. We have a diverse clinical and engineering team working here at our research and technology department here at the Glen Rose Rehabilitation Hospital. Furthermore, the students can have access to testing facilities and technologies that we have here at the ICANN Center if they need to test their prototypes. Also, being exposed to a clinical environment and the challenges that our clinical staff face every day during their clinical practice can be listed as another benefit of this project. Us as AHS employees will almost never look for an IP in the projects that we pitch to the student group. So if this project ends up being commercialized, which there is a good commercialization chance for such a project, the entire IP goes to the student team who does the project. It is also very important to mention that having such a project done improves the quality of life for our patients by a big margin. We look forward to working with the team that takes over this project, and let us know if you have any questions.